So let's start the session, my dears. So we are actually in the business mathematics subject, and all of you know we have already completed this chapter 1, that is the basic concepts of mathematics, where we have obtained the knowledge about basic mathematical skills like factorizing, solving simple equations, and solving some problems related to ratios, proportions, markups, margins, percentage, right? And we learned about sequence of numbers where the importance of geometric as well as arithmetic equations and inequalities. So we have tested our knowledge with the relevant past papers. And in the previous sessions, we have identified these learning objectives and we achieved actually. We identified the basic financial mathematical concepts like time value of money, compounding, discounting, present value, net present value, right? Loan amortization and simple interest, compound interest, how to calculate the effective interest rate, and calculate the present value and future values, and the terminal value of an investment, and the present value of an annuity, and the present value of perpetuity, NPV, amortization, and apply the interest rates for borrowing. And we achieved all these time value of money 2.1, and effective rate of interest, and present value, and discounting, as well as we studied about NPV and annuity and perpetuity, as well as this amortization schedule. Now, in today's session, we are going to test this knowledge with our past papers, right? So, in our past paper analysis and planning, my dears, already as you know, we have done some questions in the unit 1. So, actually, you can expect at least a 15 marks from the chapter 1. And the financial mathematics for a business, that is your chapter 2, actually, you can expect 20 marks questions. It means they have allocated 20 percentage from your entire syllabus for this financial mathematics for businesses. And before that, I will show you what are the equations you will get in this particular subject. In your examination, they will give you the simple interest equation, compound interest, discounting, and repayment of mortgage on loan. Most of the time, you don't need this formula. I will give you a simple way. And effective interest rate, right? So now we will start from our session from 2025 July question section A 1.2, right? So Nimal invested rupees 550,000 in a bank at the simple interest rate of 12 percentage per annum. The total interest on the investment at the end of the fourth year would be. So they're asking the total interest, not the final amount of investment. They're asking the total interest on the investment at the end of the fourth year. What could be the answer, my dear? So I'm coming to my Excel sheet right now, and I just want to write. So there's a question here, right? So here's a question. So what's the answer? Can you remember the simple interest formula we studied? The simple interest formula to get the total value P1 plus Rn. Can you remember this? This is the formula we studied for simple interest, right? So in this, the principal amount, the initial amount we are investing is 50,000. At the same time, the R 12 percentage per annum, right? For every year, we are going to get this. And we are going to invest this for 4 years. That's what it's a fourth year, the question. So the N is equal to 4. So simply we can put in the equation, that is 50,000 open bracket 1 plus R is going to be 12 percentage. So 12 percentage means 0.12. So 0.12 and times by 4 years. There's no power because it is simple interest. So we can get the answer, that is 74,000. So this 74,000 actually, my dear, this is a V value, right? The total value of your investment with the interest, that is 74,000. To find out the interest, from the total 74,000, we have to take away the 50,000, the initial investment, right? So what you will get, 74,000, take away the 50,000, you will get 25,000. So that's the interest you are going to earn for the 4 years, right? So the answer is what? The answer is going to be the second one. It's a very simple question, my dear. 3 marks. You see, the answer is going to be the second one. Do you have any doubts on this? We did so many examples, right? In the simple interest calculation. And also, you don't need to remember this formula, my dear. They will give you this simple interest. They will give S is equal to X into 1 plus NR. X normally they are representing the principal amount. S is actually the V, the value, the total sum, right? So simply remember the formula and apply it. Make sure there is no power in the formula for a simple interest, but compounding interest it will. Right? Shall I move to the next question? I need a confirmation from you. Anish, Ilma, Imat, Lamya, Subikshana, Zikra, Halima Ranas. Okay, no? If you have any questions, please let me know. So let's move to the 1.5 question from the same paper, section A. Nihal invested rupees 25,000 in a fixed deposit at the interest rate of 5% per annum, but compounded semi-annually, right? It means 5% per annum, but they are going to give the interest every 6 months. So 5% per annum means 2.5% they will give you every 6 months. The maturity value of the fixed deposit after 4 years would be to the nearest integer. Is it going to be 30,100 or 31,500 or 30,460? What is the answer? What is the answer, my dear? Here is the question. So, the value in compounding interest is P1 plus R, but we have to use the power to the n, right? So, in this question, simply the principal amount is they are going to invest rupees 25,000 in a fixed deposit, and the interest rate is going to be 5% per annum. But it's compounding semi annually in the sense every 6 months. So we need this n in the periods, like how many 6 months period will be there in a 4 years period. So we have to convert this 5% per annum into semi-annual interest rate. So 5% for a year means 2.5% per semi-annual every 6 months. So 2.5% per, sorry, semi-annually, right? So 2.5% actually 0.025. And now we have set the interest rate in semi-annual basis. So we need the total periods also in semi-annual basis. So let's say if we are having 4 years period, and in 1 year period there will be two semi-annuals, so there will be 8 periods actually. So now we can apply in the formula very simply. The principal amount, the initial amount is going to be 25,000. Open the bracket, and 1 plus R is going to be 0.025, and close the bracket, put the power is going to be with the 8 period. So you can remember here 0.025, it means the 2.5% is actually for a semi-annual every 6 months. And how many 6 months we are going to keep that? 8 6 months period. It means we are going to compound, we are going to receive the interest 2.5% for 8 periods. So Please enter it. You can get the answer 30,460.07. So you can, you know, round it off to 30,460. The maturity of the fixed deposit after 4 years is the total amount. Actually, they're asking the total amount in the question also. That's the maturity period. That's the terminal value. Right? So nearest thing. So I can choose the answer here. The answer is going to be third one. That is 30,460. Do we have any questions in this question? Do you have any doubts or any clarification do you need? No, right? Will you able to manage this kind of questions, my dears? Make sure if you are going to use the periods semi-annually, your interest rate should be semi-annual basis. If you are going to use the periods like quarterly basis, you have to use the interest every quarter. What will be the interest rate? If you are going to use the periods like for a year's annual basis, then only you can use the per annum interest rate. You have to keep that consistency. Right. Now, let's move to 1.9. Achinta obtained a loan of rupees 80,000 from a bank at an interest rate of 4% per annum compounded annually. So this is also compounding questions, but annually, right? Every year. So if it is compounded annually, we have to keep our interest rate also what? In annual basis. So the loan is to be repaid in full after 3 years. The total interest to be paid by Achinta at the end of the third year would be to the nearest integer. What's your answer? Right? Here is the question. This is also a compounding equation question, my dear. The same type of question. The principal amount is going to be 80,000. We are obtaining a bank loan. And the interest rate of 4%. So 4% per annum. And the number of period the loan is to be repaid in full after 3 years. Right? So the n is going to 3 years. So now we can keep this n in 3 years because our interest rate also per annum, annual basis. So the total interest to be paid Achinta by at the end of the third year would be. So they're asking the interest rate, not the total amount. You have to make sure that. So again, just apply the formula of compound interesting. The principal is 80,000. Open bracket 1 plus the R is we can use it 0.04 because the compounding is annually. And close the bracket, put the power, it's for 3 years. So it will give you the total amount 89,989. But the question is asking only the total interest. So you have to remove the initial investment that is 80,000 to get your total interest amount. So this is the interest amount, right? So the interest amount is 9,989.12, right? As per calculation. So it is in the third option. How simple the questions are. Here, the question answer is third option. This is compounding interest, for the last paper. Anyone have any questions? Did you understand? Anish, did you understand? Shall I get a sono quickly, please? Halina, Halima, Ranas, Ilma, Farid, Imat, Lamia, Subikshana, Zahra. Did you understand it, my dears? Okay. Right. Let's do the 1.11 because this question is actually related with other chapters also, but we will take only the portion that is related to our chapter 2. So relate the terms given on the left hand side of the following table, this side, with a number of the appropriate explanation given in the right hand side. So we will look about the compound interest only. The total sum of values in a sample of data divided by the number of values in the sample. We didn't learn anything about sampling methodology in the chapter 2. And interest accumulated from a principal sum and previously accumulated interest. So interest accumulated from a principal sum and previously accumulated interest. That's something called compound interest. Something is related. And the measure of dispersion of a set of data points around their mean. So we didn't study anything about mean and median mode. No. So actually the compound interest is related to which number, my dears? First, second, third. Which number? Very simple. This is going to be related with the second one. Why? Because compounding interest means the interest you already accumulated from your principal amount, right, will be the base of the calculation for the next year principal amount. Actually, your interest earned will earn you the interest. So the A is related to second one. That's the only part we have to know for this question 1.11, right? So you can expect more, at least a 4 or 3 MCQ questions related to our chapter 2 in terms of simple interest topic as well as compounding interest topic like this, right? And you are not going to have any questions in the section B. If you see, there is no section B question so far at the moment, right? So you will have questions in section C, that is your 25 marks questions. There may be two parts, right? A part, B part, C part, D parts. Out of that, you will have two parts, right? So most of the time, the A part and the B part, they will allocate for the chapter 2. That is financial mathematics that we are exploring now. So let's see this question. The first question is here. Zoiza Zoiza obtained a loan of rupees 300,000 from a bank at an interest rate of 20% per annum every year. And it is to be settled in equal annual installments of 3 years. So we are obtaining 300,000 loan and we have to pay every year 20%, right, as an interest. And you have to settle this in the equal installments of 3 years. Normally, the installments will be equal, right? And I told you, my dears, in the previous sessions also, always this installment amount will include the interest amount, also your loan amount, right? Now the first question is asking the calculate the annual installment of the loan. This is going to be your fixed question, my dears. Every paper you are going to have this: calculate the annual installment, calculate the annual installment, calculate the annual installment. So please make sure you are putting your attention here, because this is the continuous question, right? Now let me talk about it here. Annual installments means same amount have to be paid every year. So I'm going to highlight this word for you, right? I'm saying every year and same amount. Will you able to connect this with the topic we studied? If we are going to receive the same amount every year, or if we are going to pay same amount every year, there is a special word we can call it. If it is for a specific period, let's say for a 3 years period, we are going to pay you 100,000. For a 3 years period, 100,000, same amount for a 3 years period. There is a special word for that? Can you remember from the previous session? Anish, Ilma Farid, Imat, Lamia, Subikshana, Surikshana, Zahra. What is that? The special name. If you are receiving or if you are paying the same amount every year for a specific period, we have a special name for that. What is that? Can't you remember? Annuity, my dears. That's something called annuity. Are you are you in the class, right? See, annuity. An annuity is an arrangement to receive a specific sum of money continuously each year. And we have a formula for calculating the annuity factor also. And we have the formula how to calculate the present value of an annuity also. So the present value of an annuity is annual cash flow into annuity factor, isn't it? So this is the formula, no? This is the formula. Now, this is something related to a little bit of annuity, right? Because the present value of an annuity is equal. Present value means what? Present value means the amount of worth now, right? So this is kind of the annuity related thing. So what I can do is I will modify the formula. The present value of a loan is equal to, right, annual installment into annuity factor. So I modified the formula because we are dealing with a loan. So present value of not annuity, present value of a loan is equal to the annual installment because the same amount you are going to pay, and we need an annuity factor that's from cumulative present value table. Otherwise, we have the formula how to calculate the cumulative annuity factor, right? So now we know the present value of a loan, right? So the question is actually asking, normally this question will ask the annual installment, not the present value of a loan, because we know how much we are going to get right now as a loan. In this case, it is 300,000. So always, my dears, please remember the formula I'm going to create now. The annual installment is equal to, right, present value of loan divided by annuity factor. Simply, I took this annual installment. It is multiplication. So if we took this to the left side after equation, it will be a division. So this is the formula you have to remember for your exam purpose, right? So let's say the present value of a loan means for the moment, if you are going to take the loan, 300,000 is equal to 300,000 because there is no future now. You are going to receive the bank loan now. So the discounting factor is 1. So the present value of a loan is 300,000. Now you have to know how much the annuity factor. So the annuity factor, how to calculate? You know the knowledge, right? Either by the formula or by the, what do you call? By the table. So let's do it first by the formula. Here is the annuity factor formula. 1 over R, open bracket, 1 take away 1, fraction 1 plus R n. So let's take this formula here. First, I'll use you please remember this formula, my dears. Most of the time, they are not going to give you this formula in the examination paper, right? Right. So this annuity factor I'm going to calculate now using the second formula. 1 over R. R is going to be 20 percentage per annum. So 0.2. Then open bracket 1 take away fraction 1 open bracket 1 plus R is going to be 0.2 and closing the bracket. Power is going to be for a 3 years period. Okay. So it will give you, press ST, it will give you the annuity factor 2.10648. So we will normally take 4 decimals, right? 4 places. So 648 means if you round it off, the 4 will become 5 because the 8 is more than 5, right? So the annuity factor now, right? The annuity factor is, we can take 2.1065. So this is the annuity factor, we can use it. Otherwise, what's the other value? So I told you SIMA cumulative annuity table. Normally, I think they will give you this in the examination, right? They will give you this examination. How to do this? So simply what you have to do is just take 20 percentage for a 3 years period, right? So 3 years period is here, but maximum in this 10%. So let's do the second one. 3 years period here and 20% is here. If you take it here, 2.106 you will use. 2.106, right? So 2.106. That's the same thing, no? Now we are taking four numbers. That's a 2.1065. Otherwise, you can use this. Both are same, okay? Better remember this formula. Memorize this formula. You needed this help somewhere in the exam paper. They're not going to give you this formula, the second formula, right? So if we are using the annuity factor, now 300,000 divided by here, this is going to be your annual installment, my dear. It means every year you are going to this amount. So we calculated this for, let's fix it this for this amount, right? 142,460. That's a decimal, but we can round it off to 142,416 also. This is going to be your annual installments. It means you are going to pay for 3 years continuously. Every end of the year, you have to pay 142,416 for 3 times you have to pay, because it is going to include the interest amount as well as your loan amount also. So this is a question. Calculate the annual installment of the loan, that is for 3 marks. And the second question, prepare the amortization schedule to illustrate the repayment of the debt. Now, you know about the amortization, no? I told you the amortization table. Can you remember, my dears? Year, right? Year and our opening liability plus how much interest we have to pay for that and our installment basis, then it will end up with a closing liability for each year, right? This is the formula table. That's a table I told you, right? So now let's prepare this table from year one. So in the year one, we have taken the loan 300,000, our opening liability 300,000 at the end of the year one, right? So let's say, you know, January you are taking a bank loan 300,000. That is your opening liability. You didn't pay any down payment because this is not a lease arrangement, right? So for this you have to pay the interest. So according to the question, the interest rate you have to pay is, according to the question, there is 20% per annum, right? So the interest we have to pay end of the 1 year period for this 300,000, 20%. So 0.2, you want to multiply it by 0.2 to get this 20%. That is 60,000. Now we already calculate this installment. No? We need this installment amount to use it in our amortization schedule. Otherwise, you cannot obtain the marks for the amortization schedule. So now we know that value. We have come for 142,416, after rounded off, right? This is going to be our payment. It is including the interest also. So our closing liability is going to be 2,17,584. Now, in the second year, the 2,17,584 will become the opening liability. If you find out the 20% of these, the second year opening liability, this is the amount, then you will pay the same amount. That is what it is, an annual fixed installment. That's what we use the annuity formula to find out the installment. So now it will become 118,685. And the third year, this is the opening. And this is going to be your interest of 20% for that. Then it is going to give you 6 rupees, right? Then the fourth year, your liability is 6 rupees. For 6 rupees, you will end up with like 1.20, something kind of interest. And you don't need to pay 142,000. You have to only pay the balance 7 rupees almost, right? So then you will end up with 0. So this is how you can prepare. Otherwise, in this third installment, you can include this 7.2, but this is the actual correct method of the amortization schedule. The very important part is, end of the calculation, you have to end up with 0, because you have to pay your entire things. So in this, how much interest you paid, you have to sum it this one. If you add these all interest, so this is the entire interest amount you paid. And how much you paid actually is a cash, this is the amount, 4,27,255, right? And simply the total interest is 127,255 you paid extra than the 300,000 initial loan amount. Did you get this point? Will you able to manage this amortization schedule, my dears? Any questions? Zahra is asking, sir, can you explain the equation taking method? Okay. So equation is very simple, my dears. Use this second part equation, right? After O, use this part. It's very simple. 1 over R. R means the interest rate. That is 20%. 20% means 0.2. Open the bracket. 1 take away. 1, fraction. 1 plus 0.2. 1 plus R over N, because that is a number of years. So it will give you the annuity factor. So this is the actual formula to calculate the annuity factor. Otherwise, you can use the cumulative present value table, like where you can find out, for a 3 years period, where is a 20 percentage. So you will end up with this 2.106, right? Either method you can use it. Most of the time in the examination, they will give you the present value table and the cumulative present value table. So you can simply utilize that. You don't need to do this. But in cases, right, you have to be ready with the formula also. Guys, are you happy with this question? Will you able to manage to find out the annual installments and the amortization schedule? Halima, Ilma, Imat, Lamia, Subikshana, Shukrishana, Zahra. Yeah, okay, right? Fine. So that's the question number A part. Right. Now, there is a big part question from this 25 marks full questions. That is, ABPLC is planning to select the best project from two investment projects, Project X and Project Y. So those are mutually exclusive projects. It means you have to select only one and other one you have to exclude. So the initial investment cost is rupees 100,000 for the each project. It means if you are going to invest for X, that is 100,000. If you are going to invest in Y project also, that is 100,000. So there is no variation of investment in the beginning. And the cash flows for the next period, next 4 years of both project as follows. So they are giving the cash flows. It means the profit or cash flows. And the discounting factor, the cost of capital of the company is 10% per annum. So you are required to calculate the net present value of each project, NPV, and identify the best investment project with reasons based on the NPV. A beautiful question. And I already told about these NPV calculations and things. And let's do this question for your better understanding, my dear. See this. As I mentioned earlier, when you are calculating the NPV things, right? I said to you, it's very simple to do the questions and methodology. And give me a second. Right. I said we have to find out year, and cash flow, then discounting factor, then it will give you the present value. This is the methodology I said to you. But here, we have to calculate not only for the one project or one investment, we have to do it for two investment. We have to calculate the present value for two investments projects, that is X or Y. So what I'm going to do is, rather than calculating the first one in this table and again creating this table for the second one, we are not going to waste the time. We are not supposed to. So what I'm going to do is, what we will insert in another column, and I'm going to have this cash flows of these two projects in one table, and I'm gonna identify this is for the cash flow from project X. This is the cash flow from project Y. And the discounting factor is same. It doesn't matter project X or Y. The discounting factor is same. But the present value is going to change. So we need two present values columns for project X as well as project Y. Right? So this is how we can adjust our initial format. So it will make more sense to us in terms of calculation. Right? Now, year zero, I told you year zero in the sense it is now. Year zero means now. If we are investing something, we are in the now. Let's say the each project is going to cost you 100,000. It means the initial cash outflow in brackets 100,000 for project X and project Y. And as I mentioned earlier in the sessions also, always the discounting factor for the now moment it's 1 because we don't need to discount. It is not in the future, it is now, right? So discounting factor always 1. So the project X initial cash outflow is 100,000 and the project, how we are getting project X into discounting factor 100,000 and project Y outflow into discounting factor 1, that is going to be 100,000. Now we can do the cash flows. So let's copy the cash flows here. X 50,000, 40,000, 30,000, 10,000 in respective years. So I'm just copying here 50,000. So second, third, fourth year. So second year is going to be 40,000 cash flow. And third year 30,000 and the fourth year is going to be 10,000, right? And the project Y is going to give you 10,000, 30,000, 40,000 and 15,750. There's no scrap values. They didn't tell you about any scrap value. So Y it is going to 10,000, 30,000, 40,000 and 50,750. So these are the cash flows. So cash inflows are in positive. The cash outflow at the initial of the investment is always in the bracket. Now, we need a discounting factor, my dears. As you know, can you remember how to calculate the discounting factor? 1 over 1 plus R power n. Can you remember that? At the same time, we can get those values in the present value table also, right? So let's calculate it. 1 over 1 plus R means the discounting factor, the cost of capital is 10%. So put it in the bracket. That is 10%. So it means 1.1. If you put power 1, right? That's for a first year. It will give you 0.900. Right? We can take the three figures 0.909 for 3 figures. Right? And again, we have to change it. Only the power. If you put 2, it will give you the second year discounting factor 0.826, right? And if you change the power as a 3, it will give you this value 0.751. And if you change the power fourth one, it will give you the fourth year discounting factor 0.683. That's it. Now what do you have to do? 50,000 0.909. It means every rupee after 1 year it will become 0.909 worth in terms of today's value. So if you do this math, you will end up with these numbers. So now for the Y also 50,000, so 10,000, 0.9091 rupee worth. So the 10,000 will become 9,950. Then these are the values you will get it. Now, my dears, we can add this. The sum is going to be 7,850. This is going to be 1,450. This is going to NPV. As you know, if the NPV is in the plus, we will select that project. Because even if you cover the 100,000 and we converted these all 50,000, 40,000, 30,000 in today's worth also, after that also it is giving some profit. So it is worth to consider this project. It means rather than investing in other 10 percentage business opportunities, you can invest this project because it is going to give you more than 10 percentage, right? But project Y, if you have the opportunity to invest this money, this 100,000 money in another things, you can earn 10,000. But if you are going to invest this project Y, you will lose your money of 1,428 in today's terms at least. So which project we have to select? Because the plus NPV, the NPV is positive in project X. So we have to select project X. That's it. Any questions? This is how we have to deal with this NPV. So 4 marks for the NPV calculation and identify the best investment project with the reasons based on the NPV because the NPV is positive for the project X. That's what we are choosing. If you write it that one, that's a 2 marks, right? So you can see the answers also. Okay. The net present value of the project X is positive. Project Y has a negative NPV. So therefore, project X is the best investment. Right? So this is how you have to do the questions. This is how most of the questions, all of the questions will be the same type. Right? So let's move to 2025 January paper section A 1.2. Here's the question. The company is planning to make an investment project. The net cash inflow of the investment project for the next 3 years is rupees 50,000 per year. The cost of capital, it means the discounting factor of the company is 10% per annum, and the initial investment cost of the project is rupees 100,000. The net present value of the project would be so. The same question it is applicable to the NPV calculation, a kind of same question, right? Will you able to calculate it, my dear? What is your answer? The question is asking the NPV. So if they're asking the NPV, yes, as well as there is no two projects, only one project. So we don't need to divide the cash flow into two columns. And we need the discounting factor and we need the present value, right? So in the year zero, the company is planning to make an investment. The net cash inflow of the investment project for the next 3 years is 50,000. So 1, 2, 3, you are going to get 3,000. 50,000, right? So 50,000, again another 50,000, again another 50,000. The cost of capital of the company is 10% per annum. So the discounting factor we are going to use is 10%. And the initial investment cost of the project is 100,000. So the cash outflow at the initial zero now, right? It is 100,000. So the discounting factor always 1. So 100,000 into 1, it's going to be 100,000 in the bracket. Right? So the project, the net present value, they're asking the net present. We need the discounting factor. So since already we have calculated these values, I'm going to use these values, my dears. Right? The same value will come. You can calculate or you can find it in the present value table, or otherwise you can memorize the 5 years actually discounting factor. So no need to calculate. You can serve the time if you remember, memorize this because it's always it's going to be the same thing, no? Right? So now you can find out 50,000 into 0.90 like that. This is going to be the number. And if you sum it up, this is going to give you the 24,300. That is the NPV. Since this NPV is going to be in positive value, you can expect you can accept this project actually. So the question is the net present value of the project would be to the nearest is 24,300. So this is going to be the answer. The answer is in the fourth one. And also, will you able to remember, my dears, this is 50,000, right? First year, second year, third year, this is an annuity, right? Then the same amount. So there is another method also you can follow here. Let's say if I am here to save the time, from first year to third year, right? From the first year to third year, you are going to receive the same amount. So now what I will do is rather than using the present value table, I can use the compounding. It means the cumulative present value table for 3 years, 10 percentage, right? So here for a 3 years period, 3 years, 10 percentage, it's here 2.487, right? It's going to be 2.487, right? If it is, right, if we multiply it, this is going to be 124 here, 50,000 into 2.487, 124,350. And even if you sum it, it will give you the same answer. This is the NPV. Both method you can use it because this 50,000, 50,000, 50,000 for a 3 years period, this is actually annuity. So for a 50,000, the annuity factor for a 3 years period at the 10 percentage, right? If you add this, right, 0.909, 0.826, 0.751, you can have here 2.486. So almost that is the cumulative present value table. That's what we are saying, cumulative present value table, because the amount is same. It's not going to vary. So you can use that also, right? So the same answer you will get it. Any questions in this method? So if the cash flow is the same amount for a particular period, you can use the annuity factor rather than calculating one by one. If the cash flow is different, you can't do because that's not a feature of annuity. Annuity is always every year the same amount for a specific period. You got it, Anis, Ilma Farid, Imat, Lamya, Shubhikshana, Sukrishana, Zahra. Right? Very simple, right? Very simple and very methodological. Right. So 24,300, right? So the fourth one is the answer. Now let's do the 1.8 also. Satish borrowed a loan of rupees 165,000 from a friend at an interest rate of 8% per annum, payable in 3 years. And interest rate is calculated based on the simple interest. So the total interest to be paid by Satish at the end of the third year would be. Again, the question is all about simple interest, right? It is simple interest. So what is the answer? Can you please let me know the answer, my dears? Because we did so many questions, right? Shukrishana choosing the second one. What about other people? Let's remember the formula. The value is going to P 1 plus Rn. There is no power because it's a simple interest. And the question is asking actually the interest. Let's identify the P value. The P value is going to be 165,000. That is the borrowed loan of 165,000 from a friend at an interest rate. R is going to be 8% per annum. Payable in 3 years. So N is going to be 3 years. Right? It is in simple interest. So let's find out the total value first. 165,000. Open the bracket. 1 plus R is going to be 0.08 because it is 8% into 3 years. Close the bracket. You're going to have this amount. This is the total value after 3 years. So take away the 165,000, that is your initial loan amount. So 39,600 is going to be the interest amount that is in the second one, right? So second one is the answer. Very simple question, my dears. Second one is the answer here. 1.8. So let's discuss this 1.11. Here you have to find out the term annuity is related with which explanation. Is it the relationship between two quantitative variables, or an investment into which equal annual installment is paid in order to earn interest, or an arrangement by which a person receives or pays a series of constant amount? What is that? Which is the best option? The third one, right? An arrangement by which a person receives or pays a series of constant amount. Constant amount means at a fixed amount, the same amount. So the B is actually related with the third option. An investment into which equal annual installment is paid in order to earn an interest is called sinking fund, my dears. But annuity, we can receive or we can pay. It's not only the payment side, but sinking side is a payment side. We can receive the same amount of money. So annuity is in both sides. So an arrangement by which a person receives or pays a series of constant amount for a specific period, right? And as usual, section C, we are going to have questions from A part and B part. You see. The first one, Judy plans to obtain a student loan of rupees 600,000 from a bank to be paid in 3 years at an interest rate of 10% per annum in order to complete her higher studies. She intends to settle the loan in equal annual installments. Again, the same question. You are required to calculate the annual installment of the loan, prepare the amortization schedule to illustrate the repayments of the loan. Right. So the same type of question we have done already, and I will do it quickly now. The first question is about annual installment, my dears. Can you remember the formula we have built? The annual installment is equal to the present value of the loan, and I set it's divided by the annuity factor, because annual installment always a constant amount we are going to pay for a specific period. That period is 3 years in the question. So the present value of the loan is the nowadays value, it is 600,000. So we must find out the annuity factor. So I can remember the formula. If you do the formula, you will remember the formula quickly. So 1 over R. R is 10% per annum, means 1, I think 1 plus, right here, no? 1 over R. 0 point, let's take this here. Okay. So 0.1, then open bracket, 1 take away fraction 1 divided by 1 plus R is going to be 0.1. You have to put it into the bracket. Then we have a power. The N is 3 years period. Then close the bracket. It's going to give you the factor 2.4868. So we can round it off to 2.48685 is there. So we can take it as a 9, right? Then you will get the annual installment, this amount, right? We can round it off to 2,41,264 is going to be your annual installment. And prepare the amortization schedule to illustrate the repayment of the loan, right? Now you know how to prepare the amortization, right? Year will be there. Sorry. Yes, year will be there. And we will have opening liability. For this opening liability, we have to pay interest. In this question, we have to pay 10% per annum. And for the liability and also for the interest, we will settle installments amount, that is the annual installment, the same amount every year. Then we will end up with our closing liability, right? So then we can develop our table. So in the year one, we are taking 600,000 loan, right? We are taking 600,000 loan. And the interest for this 600,000 is 60,000. And the installments we have calculated here 2,41,264. We will settle this for interest as well as for the loan amount. So you will end up with this amount, right? So in the second year, the opening liability will become the closing liability of the previous year. And this is the interest. This is the same amount will be the installment. And this will be this. And the third, the opening liability is this. The 10% is this. Then here is the same amount. So 16 rupees. In the fourth year, this is your opening liability for this. Right. So you have to pay the amount for the opening liability and installment fully to clear the payment. So then you will end up with zero values, right? This is practically the amortization schedule. We have to get our loan to zero. And how much the interest they have paid totally? This is the interest amount they have paid, right? The full amount they have paid is this, right? How much the full cash they have paid? This is the value, no? Right? Did you understand, my dears? Any questions? Anish, Ilma Farid, Imad, Lamia, Subikshana, Sukrishana, Zahra. Did you able to understand the question? It's more simple, more easy than you think, right? So let's move to the B question. Riza deposited rupees 8 million at a bank that pays interest at an annual rate of 12% per annum. And the interest is compounded quarterly. Quarterly means every 3 months. So you are required to calculate the effective interest rate, right? So effective interest rate and the total amount in the fixed deposit at the end of the third year and the total interest earned by Riza at the end of the third year, right? So this question is actually they are connecting the effective interest rate also. That's a true real annual interest rate. That is something called effective interest rate. So it's actually effective annual interest rate, EIR, right? So we have formula, right, for the effective interest rate, and as well as they will issue this formula in your examination also. This is a formula, the effective interest rate calculation formula. Let's take this formula here. This is the formula, right? So using this formula, we can calculate the effective interest rate. But we want to make sure the rate as well as the period should be aligning. You know, the interest at an annual rate of 12% per annum and the interest is compounded quarterly. So the periods we have to keep in our mind, it is every quarter. So every quarter in the sense, my dear, there are 4 quarters, right? 4 quarters in an year. So 12 percentage per annum is compounded quarterly, right? Pays interest at an annual rate of 12 percentage per annum and the interest compounded quarterly. So we have to take the quarterly interest rate. So our R value now, we have to take the quarterly value. So 12 percentage divided by 4, because we have to take it quarterly interest rate. So 12 percentage divided by, 12 percentage is per annum. So 3 percentage per quarter, right? So end of year, we can get the 12 percentage. So it means 0.03 is the R. And the end, how many quarters are available in 1 year? That is going to be 4 periods. Because we are going to calculate annual installment, annual effective interest rate. So now we can apply in the formula, open bracket and another bracket, 1 plus R. R is going to be 0.03. And close the bracket, put the power, n is going to be 4 periods, and take away 1, get the answer, multiply it by 100 to take the percentage value. So 12.550, so we can come across 12.55 percentage actually the annual interest rate, but not 12 percentage, because in simple words we can say it's a 12 percentage, but actually you're going to have 12.55 percentage as a real effective interest rate, right? So the effective interest rate is going to be 12.55 percentage. That's the answer for a 2 marks question. And the B question, total amount in the fixed deposit at the end of the third year. So this is actually compounding interest. So V is equal to P into 1 plus R power N, right? So we need it. So it's just a compounding interest question. So what is the principal amount we are depositing is 8 million, right? It is going to be 8 million. Open the bracket. 8 million means 8,000 and again 1,000, right? So 8 million and open bracket 1 plus R. So R is going to be total amount in the fixed deposit at the end of the third year, and it is the compounding quarterly. So we have to use what rate? We have to use the annual, quarter rate, 0.3. So 1.03 right, let's put it like that, 1 plus 0.03, and how many periods it's going to be actually, as I mentioned earlier, for a 3 years period, right? For a 3 years period, how many quarters will be there? In 1 year, there will be 4 quarters. For 3 years periods, 3 into 4, 12 periods. So you will get this number. So this number 11406087.09, right? So this is the total amount of in the fixed deposit at the end of the third years. And the total interest earned by the RISA at the end of the year is, this is the total value. Take away the initial 8 million, 3.4 million. Let's confirm this answer by their suggested solution, my dears. Effective interest rate is 12.55 percentage. That's what we have calculated. So our A question is correct, right? And let's see the B question part is 11,400 and 8,000. 11,406 something, because they have rounded off. We didn't round it off, but the idea is same. 8 million is the amount. N is 3 years and 0.12 r n is equal to 4. So here's the formula: 8 million 1 plus 0.12 divided by 4. So they're actually using 0.03 and 3 into 4. So it's correct. But what has happened is they have taken this value into 3 decimals, but we actually taken the full value. That's why it is different. But that answer is correct. You don't need to worry about the exact sense, right? This is actually correct because we use this correctly. Right. They will give you the marks for this, okay? And the C part is, if you deduct it, actually it's going to, you know, yeah. The total interest earned by Risa is 3,408,000. But it will be different because our calculation is very accurate. We are not round it off. If you round it off, right, what they have did is they have rounded off. Let's say first they have calculated this part, 1 plus Rn, like, 1.03 open bracket, and for a 12 periods it will give you this, no? So we have used this full amount, but what they have done is they have taken the four values: 1.4258, right? 1.426 they have taken, so 1.426, only 3 decimals. So if you take this number, let's say 1.426, 1.426, then if you times by the value, the initial value in the question, 8 million, you will end up with the same answer. But our answer is so accurate, right? They rounded off. The method is very important, not the, number by number answers. They don't care whether you are trying accurately or not, right? That's what's here important. Right. So this is the correct answer, my dears. And let's move to the other paper also. So A question and the B question is done. In 2024 July, there are 2 questions, MCQ questions. You're going to answer for me. Silva invests rupees 60,000 in a savings account at the end of each year for 5 years at the interest of 5% per annum. Compounded annually, the present value of the annuity at the end of 5th year would be. What's your answer? Present value of the annuity. Can you remember present value of annuity formula? Always annual cash flow times by annuity factor. So invest rupees 60,000 in a savings account at the end of each year for 5 years at the interest of 5%. So the annual cash flow is 60,000 and we have to find out the annuity factor. So for that annuity factor, whether we can use the formula or the table. So here 5 years 5%. Simply we will use it. 5 years 5%. Here 4.329. So 4.329. Right? Check the answer. 4.329, it will give you 2,59,740. Right? So third one is the answer. Otherwise, you can use the formula. Right? Third one is the answer. If you use the formula also, you are going to have the same answer. And the other one, a person has a fixed deposit of rupees 200,000 in a bank at an annual interest rate of 12% compounded quarterly. So the maturity value of the fixed deposit after 3 years. So always, my dears, you have to take care of the compounding periods. Then after that, we have to adjust that compounding period for our interest rate. Right? First priority is we have to give for the compounding, right? Whether it's compounding quarterly, annually, or whatever. So a person has a fixed deposit of 200,000. So the formula will start like this: 200,000 open bracket, 1 plus Rn. Because since it is quarterly, we have to calculate this annual interest rate to quarterly. So 12 percentage means divide by 4 because there are 4 quarters. It will give you 0.03 quarterly interest rate. And how many periods? The maturity value of the fixed deposit is 3 years, and each year there will be 4 quarters. So 3 into 4, there will be 12 periods. So this is going to be the correct answer, 2,85,152. But there is no such an answer. It means what? It means they didn't take the full value, they rounded off this value, right? So if they did something like that, we can do like this. Let's take this 200,000 now from the calculator. First find out this value, 1.425. So what we can do is we can take 3 digits numbers, 1.425. There's a 7 there, so we can take 1.426. This is the annuity factor, no? So this is going to be the thing we have to multiply, right? By this 200,000. So now if you did that one, let's take 200,000 into 1.426, 2,85,200. So that's going to be the answer. Normally they will take the 3 digits only. They're not going to expect you to calculate very accurately. So the answer is going to be the second one, right? Second one is the answer. Right. Zahra, please ask me specifically, what you are trying to understand. And again, another question, calculate the annual installment loan and calculate the NPV, choose the best option, right? Those are very, very simple question. Anyhow, I'll do it for you. These kind of questions, again, they are repeating the same methodology from you. Right. As I mentioned to you earlier, my dears, how to calculate the annual installment? Actually, the present value of a loan divided by annuity factor. This is our formula. How to find the annuity factor? Either by formula or by using the annuity, cumulative present value table. Here see, Amal borrowed a loan of rupees 500,000. Okay, 500,000 is here. From a bank and an interest rate of 13% per annum, and it should be settled in equal annual installment of 5 years. So we have to find out 5 years, 13%. So 5 years is here, 13%. Okay, we have to use the second one. 5 years is here, 13% is here, 3.517. Right? So 3.517. So you can get your exactly, this is going to be your annual installment, right? They are not asking the amortization schedule in this question. So this is going to be your annual installment, right? And other question is, an export company is trying to choose the best investment project from X and project Y. The initial investment cost is rupees 500,000 for each product. And the net cash inflows for the next 3 years are as follows. The discounting factor is 12% per annum. Calculate the net present value of each project. Identify the best investment option. So a similar question. There is no change. There is no twist. So I can use these, the table, right? We have to choose it. So I'm going to take this table format for the easiness, right? But I'm going to delete everything here. This is also project X and project Y. So the initial investment is 500,000. Here also it is going to be 500,000. But the discount factor you have to use is 12% rather than, right? My dears, you can't remember this, okay? As I mentioned earlier, 10%, 1 year is going to be only, this here. For a 10%, 1 year 0.909. If it is changed by the interest rate change, the amount will be changed, okay? Don't remember like 1 year, 2 years, third year, this is the exact amount. No. We have to match the interest rate also, right? So be very careful there. Better always calculate it. Otherwise, take from the present value table. Right. So the discounting factor always is going to be 1. So 500,000 into 1 is 500,000. And 500,000 into 1 is going to be 500,000. So the project X has a cash flows of 150,000, 220,000, 260,000. That's it, right? There's no fourth year. And here 190,000, 210,000, 300,000. So the discounting factor, we can use the formula, 1 divided by 1 plus R 1.12. The power is going to be 1 for a first year. So it will give you this one. 0.8928, so 893, we can round it off. Then if you change the power to the 2, it will give you the second year present value table, present value factor, discounting factor, 0.7971, so we can keep it as 0.797. And if you change the power to the 3, it will give you the third year at 12 percentage interest rate, that is 0.7117, so 0.712. Okay. So now you can find out all the values. If you multiply it, you can get it. Also, you can get these values, right? Now you can understand the project X is giving the negative NPV, project Y is giving the positive NPV. So you have to choose project Y. Since the NPV is positive for project Y. Let's see the answers also for the correctness checking. Okay, 5,590, 50,640. Yeah, correct, right? So the end of the day, we have to give this wording. The wording is here. The NPV, the net present value of the project Y is positive. Project X has a negative NPV. So therefore, project Y is the best investment to choose. How simple the questions are, my dears. You don't need to worry much about this paper. This is very simple paper. And let's do the 2024 January also. Uh, 1.9 we have done, right? Right. Okay, 2024 January paper here. Sudhakar invested rupees 400,000 in a fixed deposit at the annual interest rate of 8% compounded annually. Total interest on the investment at the end of the fourth year would be. So this is also a very simple question, my dear. You have to check the compounding is happening in quarterly, annually. That's main thing, right? If you crack that idea, then the paper is very simple paper for you, right? So compounded annually. So it's a simple compounding interest question. So this is the 400,000. It's going to be your principal amount and 1 plus R. 8% compounded annually. So we can use the annual rate. No need to calculate it. 0.08. And the power, because it's a compounding, the total interest on the investment at the end of the fourth year. So there are 4 years. So it will give you the total value. What happened? Okay. And to find out the total interest, We have to remove this 400,000. 1,44,195.5. So we can write it down to 1,44,196. That's the first option, right? Yes, the first option is the answer. And the second question is, Tamosha wanted to invest rupees 55,000 in a bank at the rate of 16 percentage per annum. If the interest is compounded quarterly, the annual effective interest rate would be, right? So they're asking the annual effective interest rate. So for that, we must know the annual effective interest rate formula. It's here. It's actually in your exam paper, so you don't need to memorize it. Just utilize this in your examination. That's what they have expecting. But it is important, it is compounded quarterly. So you have to convert your annual interest rate into quarterly. So the R is going to be 16 percentage per annum in the sense. So quarterly means there are 4 quarters. So you have to divide 16 into 4, right? 16 into 4 will give you 4 percentage. So 4 percentage per quarter, it means 0.04 is the R value. And the N value for 1 year, how many quarters will be there? There will be 4 quarters. So then now you can apply in the interest rate calculation. Open bracket, another bracket, 1 plus R. R is going to be 0.04 per quarter. Close the bracket, put the power, N is going to be 4 period and minus 1 and times by 100 to get the exact percentage value. This is the value 16.985 is there. So 985, so 99, we can keep it. 16 point, yeah, we can keep it 16.98, no? 98 because the 5 is there, no? So 16.98, that is going to be the first option. Right. Yes, first option is the answer. And 1.9, Ranjan borrowed a loan of rupees 2 million from a bank to start a business. He agreed to repay the loan over 5 years in equal annual installments at 12 percentage per annum. The annual installment of the loan would be to the nearest integer. So again, they are asking the same type of question to calculate the annual installment amount, right? As I mentioned earlier, there is a formula to calculate the annual installment, that is present value of loan divided by the annuity factor, right? The present value is 2 million. The annuity factor, we can use it, 5 years, 12 percentage. So 12 percentage for 5 years, it will give you 3.605. Five lakhs 54,785. Directly the answer is there in the second one. Okay. Second one is the answer. And 1.11, Fisher's interest net present value. Now we will identify net present value explanation. Present value of cash flows over a period of time. The index that base year's quantities must be chosen as weights. The geometric means of lay space and passage index repeated movements involved in a period of time. What is this? Net present value means the present value of cash flows over a period of time, right? We are calculating that over a 5 period of time. What are the cash flow we are having? We are turning that future values into present value and we are summing all the things. We are adding all the things. That is NPV. So B is actually connected with first one, right? And let's move to section 6 also. So here also they are the first one. Manoj obtained a loan from a bank for 4 years at the rate of 12% per annum. It is to be repaid in equal annual installments of rupees 65,848. Calculate the amount of the loan obtained by Manoj. So now we have to find out the present value of the loan. They have already given you the annual installment amount, but we have to find out the 4 years 12% annuity factor. So automatically we can get the present value of the loan, no? And prepare the amortization schedule to illustrate the repayments of the loan. Same thing again. And calculate the NPV, identify the best investment options. There's nothing else, just follow the structure. So I hope so you can do all the questions hereafter, my dears, right? Without my help also. So I will give you what are the questions you have to practice in this financial mathematics in these questions in the group. So you can practice it. It's the same methodology. They will ask the amortization schedule, annual installment, simple interest calculation, compounding interest calculation, effective rate of interest, the topics we have discussed only. As well as you have to remember only one formula, annuity factor, how to calculate the annuity factor, because you are going to have the simple interest, compound interest, discounting, as well as the effective interest rate formulas also in your examination, right? I think that's it for chapter 2. You can practice the questions. And let's see all of you in the next session with the financial operative measures for a business. It is actually a pure great, my dears. The 10 marks you will obtain very easily. It is so interesting. And let's see all of you in the chapter 3 while you are practicing in the chapter 2 other past paper questions, right? So thank you for being in the class. Let's see all of you in the next classes. Have a great day. Thank you. Bye. See you.